Hello and welcome to my conceptual school mathematics channel. This channel contains short and sweet videos of mathematics lesson useful for teachers and students and also for the flip classroom. Please subscribe and press the bell icon to keep in touch with latest uploads. Today we are going to study about set and its representation in Venn diagram. This lesson is very useful for the students who are studying from grade 4 to grade 8. First of all, let's discuss what is set. Set is the collection of well-defined objects. Almost every book we read this definition, but what is well defined? Let's take a simple example. Here is a set having elements A, B, C, D and E. Can we describe or define the collection? Yes, definitely we can. We can describe or define the collection as English alphabet. More precisely, the first 5 English alphabet. That's why this is well defined. But look at here the other set. There are the elements A, B, C, D and all of a sudden potato comes. What is potato? That's quite different from A, B, C, D. We cannot define this collectively. That's why this is not well defined and this cannot be described as set. Now let's discuss about Venn diagram. Dear friend, John Venn was an English mathematician, logician and philosopher noted for introducing the Venn diagram concept. To study Venn diagram, we must know the concept of a universal set. Universal set is the largest set in the problem containing all possible elements of any set we wish to consider. In Venn diagram, universal set is represented by a rectangular set denoted by U, from which the different sets are obtained and put in circular shape. Here we go. Here is a Venn diagram consisting of a universal set U, set A and set B. Let's implement the concept with a problem. Here, let the universal set U equals to 1, 2, 3 up to 10. That means 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. There is a set A obtained from U whose elements are 2, 4, 6, 8 and 10. And there is another set B having elements 1, 2, 3, 4 and 5. We're gonna represent the given set in Venn diagram. Let's rewrite the problem with appropriate space and let's construct a Venn diagram having universal set U, a circular region of set A and the circular region of set B. To fill the elements in Venn diagram, first of all, we have to identify the common elements of the set. Here, 2 and 4 are two common elements of set A and B. Now, we're gonna put the common element in the common region of A and B. Here we go. Now, we have already put 2 and 4 in the Venn diagram. That's why we cannot put it again because there is no repetition in the set. Now, let's see the remaining elements of a set A. The remaining elements are 6, 8 and 10, which are gonna be put in the remaining space of the region A in the Venn diagram. And similarly, the remaining element of B are put in the remaining region of set B in the Venn diagram. Here we go. At last, observe the universal set U. Since we cannot repeat the elements in the set as well as in the Venn diagram, let's hide the element which are already put in below Venn diagram. Here, 1 is already gone. That's why 1 is hidden. Similarly, 2 already put in the Venn diagram. 3 is already put. Similarly, 4 is already put. 5 is already put in the remaining section of B. 6 is already put in the Venn diagram. 7 is not in the Venn diagram. 8 is there in the remaining region of A and 10 is also there. So, the remaining elements 7 and 9 neither belongs to A nor belongs to B. Must be put outside the region of A and B as shown in the video. Now, let's discuss about the operation of the set. First of all, intersection of set. Here, A and B are two sets. That's why A intersection B is denoted by A and opposite U. B is a set of all common elements of A and B. The elements put in the common region of A and B are the elements of A intersection B. That is, A intersection B equals to 2 and 4. And see that A intersection B is cited in the Venn diagram. Let's go to the union of sets. A union B is denoted by A and there is a symbol like U, capital U. A union B is a set of all elements of A and B. So, A union B contains all elements of A and B without repetition. Here, A union B equals to 1, 2, 3, 4, 5, 6, 8 and 10. And you can see in the video the region A union B is cited here. Now, let's go to the difference. Here are two sets A and B. A difference B is denoted by A minus B, means the elements of A which are not the elements of B. Here you can see the shaded region of A minus B containing the elements 6, 8 and 10. Similarly, collection of elements of B which are not the elements of A is called the set B minus A as shown in the video. The shaded region is B minus A having elements 1, 3 and 5. Let's go to the complement of set. First, complement of A. complement of A is denoted by A dash or A bar is the set of all elements of the universal set which are not the elements of A. So if we remove all the elements of A from the universal set, the remaining elements will form the set of A complement. Here the shaded region represents the set A complement and the elements are 1, 3, 5, 7 and 9, all of which lie outside the circular region of A in the Venn diagram. Similarly, the region outside the circle B in the Venn diagram is called B complement, containing the elements 6, 7, 8, 9 and 10. Similarly, complement of A intersection B denoted by A intersection B dash or A intersection B bar is the set of all elements of universal set which are not the elements of A intersection B. So, like in the given Venn diagram, all elements lying outside the region of A intersection B form a set called A intersection B complement. Similarly, all the elements which are outside the region of A union B is called A union B complement, containing the elements 7 and 9. At last, but not the least, the boss of the set. Universal set is the largest set containing all the things, all the elements of the given problem. It's the boss of all the sets. Please subscribe, like and provide feedback. Thanks for watching. Bye bye.